Hello and welcome to the panel discussion. We have a great panel covering different dimensions of smart cities, policymakers, solution providers, operators, and innovators today with us. Let me welcome my panel. Farabi Yusufa is the head of Smart Cities Plan Malaysia. He comes with a very rich experience in policy making related to urbanization, smart cities, and physical planning. Charmaine Wong is a manager, Smart City Division, JTC Singapore. Charmaine leads the artificial intelligence and machine learning team at JTC Smart District Division and drives AI development strategy for smart estates. Jian is the vice president and general manager, Eurasian business development at Neoway. Neoway is a dedicated providing IoT access communication products and services for customers, including industrial Internet of Things, service providers, and smart connected product manufacturers. Welcome once again. Let me start the discussion by asking question to Farabi on the, especially on his from his experience on the urban planning. A lot of importance is given to physical planning of cities. Do you see it's important to do a detailed digital master planning in parallel with physical planning of the cities? What's your view on this?
Okay, thank you very much, Sadvik. And good morning to everyone, I believe. And yes, I think your question is about digital master planning is an emerging strategic practice in global cities. The digital master plan provides both a conceptual design and comprehensive implementation roadmap for ICT infrastructure, system, and digital technologies that can be applied to a site, district, city, or major event or a greenfield project. To a certain extent, people are talking about the digital twin for now. So a digital twin is a virtual representation of an object or system that is spent its life cycle, is updated from a real-time data and use simulation, machine learning, reasoning to help decision making. In my view, especially in my job scope now, the digital master plan need what we call is smart city planning. So the planning process, especially in Malaysia, we have a 4-tier process, namely at the national, involve ministry at level 1. Second is at the regional and state level. And the third level is the local planning. And this local planning, we have another level we call as a development control. So this smart city planning is being translated by all levels, having different levels and different perspective. For example, at the national level, we have a Malaysian smart city framework as a guide, act as the textbook for the smart city planning. And at the state level, we have a smart city blueprint, state level, statewide documentation. And at the local level, which is the local government level, we have smart city action plan, that project-based document or action-oriented document that be used to the local authorities as a reference. So the lower tier of the plan is very important to translate all policies at higher level to the implementation level. And definitely considering Malaysia have more than 200 plus cities governed by 154 local government, we believe that every cities have their uniqueness based on the locality, and implementation strategy will be different. So apart from that, city also could plan their budgetary system accordingly based on prioritization. We know that there is a sky as a limit to the local government spending, and through the smart city planning, or you can call as digital planning as well, we can focus on which smart initiatives to give priorities, and it should be based on the people-centric smart city evaluation.
Thank you, Farabi. Maybe from planning to move towards more of the development and situation of smart cities in real implementation stage, right? My question would be to Jian. So what is the current situation of smart city construction development in China, and what are some of the challenges, problems that you see in that direction?
Yeah, I'd like to say in China, actually, we spent so many years to develop smart city. And from 2008, that is the concept period. And we already establish such kind of smart city concept. Now, after that, we enter the second phase, is a standardization. Then is the strategic breakthrough. Now is the fourth phase, we called comprehensive development. So during those 14 years development, I can say that we have made a lot of issues. So I'm very happy to share some of the experience with us. I think the first issue we have made is we pay more attention to the concept, but less application. You know, at the beginning of the smart city, everyone just wants to use this concept and to build a lot of projects. We call it image project. We invest a lot in the hardware, in the building, but actually there's no very good content inside. Okay, this is one of the issue. The second one can say is we put more attention on the system side, but less on the data side. We built the smart city system, but actually the core of the smart city is the data. How to use the data, how to share the data. This is the most important item, I can say. Then the third problem is I think we put more attention on the path, but less on the coordination. You know, smart city, you have so many layers of government, district or municipality. Also, you have different departments inside the city. So every department or every labor, they build their own system, but there's less coordination on the top. And the fourth issue we made is we have common needs, but very less individual, okay? Because the smart city is not just a technical issue. The purpose of smart city is to use technology to fix the issue in the city management. So you cannot just use one common technology to cover all the requirements. We need to have individual solution for each application. So those 4 pain points, I can say, is what the most problem we have made before in the last 14 years. Thank you.
Thanks, Ian. I think very valid point and a realistic view of the challenges that we face. I think from Malaysia and China, now let's get into Singapore, some of the developments. And maybe my question would be to Charmaine. We all know Punggol Digital District is a very ambitious, forward-looking smart estate project. Operating system for an estate or a city sounds very exciting. How is the vision of smart estate operating system is becoming a reality? And can you provide some insights on the progress that is happening? So we're all looking forward to seeing the PDD. So any insights on that will be useful, Charmaine.
Sure, thanks, Sadvik. Perhaps before I provide insights on the progress of the Open Digital Platform, let me give a bit of a background to JDC for the benefit of our foreign attendees and our friends here. Right, so JDC is a statutory board under Singapore's Ministry of Trade and Industry. What we do here is we do planning, development, and management of sustainable industrial estates such as Jurong Innovation District, and also business parks like One North and Punggol Digital District. So what we are doing at Punggol Digital District, or PDD for short, we are developing Singapore's first tech-enabled and sustainable smart district. So this actually forms the cornerstone of our smart nation ambitions. So in terms of what PDD is, it is a 50-hectare mixed-use district that is currently being master planned and developed by JTC. So what's inside PDD are things like your educational institutes such as SIT's campus, JTC's business park buildings, and also shared business, shared public spaces and community facilities. So the intention for PDD is to be this living lab for the experimentation and so the development of smart solutions. And so I hope that all these trials that we do in the district can be scaled to different business districts or even across Singapore in future. So in a nutshell, PDD will be the first digital district in Singapore with full integration of digital infrastructure and smart technologies. And this is made possible through the Open Digital Platform, or the ODP for short. So this is the platform that is currently being built by JTC together with GovTech and ST Engineering. And it's hoped that this will serve as the digital backbone for the district. So in terms of what kind of capabilities ODP has, we have digital twin, we have command and control communications, or C3 for short, and we also have AI ML capabilities that will allow us to collect all this IoT data, visualize them, and also analyze them. So perhaps let me dwell a bit more onto how ODP actually helps to enable this smart ecosystem in PDD before I move on to talk about the progress that we have achieved so far, right? So for ODP itself, it actually builds this ecosystem through several different layers. So your first layer is always setting up of a digital infrastructure. So your fixed and wireless communications, your IoT networks, your sensors and devices, this forms the first layer, where you actually start to collect and stream all this real-time data from within the estate. So after that, we then have this digital platform, the C3 operating system, where you are able to visualize all your different smart systems being tied up to a single operating system platform. So we are able to visualize all your connected smart systems in a single view and also in real time. And then after which we can then layer on a layer of connected intelligence through things like AI machine learning. We can do modeling and simulations, just like what Paravi mentioned about digital twin. So we have this digital twin capability that allows us to carry out modeling and simulation without having to actually do things within the district itself. So we don't compromise any operations in the real world. So, and the final layer really is the connection to the people, right? The people in the district, the companies that can come and work and test big the solutions upon the ODP. So ODP essentially offers this interoperable layer for more apps and services that can be built by third-party operators. So in terms of progress, currently we are in the midst of setting the ground for deploying ODP at PDD in 2024. So that's also when our business parks will gradually open. And what we're doing basically is to procure and test all the smart systems that we'll be installing at PDD. So things like your lifts, right? We have asked our vendors to send us a sandbox so that we can start testing and start working on the system to see, what kind of data we can get out of the system. So we are also using JDC Summit as a test bed for use cases that we are looking to push forth at PDD. So the good news is we have also recently commissioned ODP at JDC Summit in January this year, so just a month ago. So we have also linked up verticals such as your lifts, your escalators, your doors, your CCTVs. All these are being linked up from Brownfield site, which is JDC Summit. It's actually a pretty old building. It was built in 2000. So all these old legacy systems have been linked up to the ODP. So now we are able to test out whatever smart use cases we want to do at PDD. We can also try them at JDC Summit right now. And I think maybe just one more nugget of information. We have recently completed a proof of concept for autonomous delivery robots with Continental. So they have actually successfully delivered their food. Okay, their robot has actually successfully delivered food from Westgate, which is a nearby shopping mall, to JDC Summit building. So I think this is where we are at the moment. We have made pretty good progress, and we are excited to see what else we can do in JDC Summit and ODP and in PDD alike.
Thank you, Shaman. Amazing. So we are also looking forward to it. Very exciting. Thank you. Yeah, again, my next question would be to Farabi. What are some of your favorite IoT analytics use cases when it comes to smart cities, Farabi? So we heard few from Sharmain. What are your favorites?
Yeah, okay. Definitely, there is a lot of favorite, especially when we talk about the Internet of Things, because this technology can do magnificent solutions. So, but I think just try to be fair to the all audience that we have. So probably I try to recap. Smart city use sensors and connected devices to collect and analyze data. So this data is used to optimize city operation, manage resources, and improve the everyday life of the citizen. So smart cities utilize technology to improve the access to the public transport, manage traffic, optimize water and power supply, and also improve different services such as, for example, education, health, safety, and others. So among two that really close to my heart is actually, one is smart transportation, or we call it in Malaysia, we have smart mobility. So this one of the smart mobility is try to improve the traffic management. We know in Malaysia is a traffic congestion is one of the biggest issues that we faces in most of the cities. So improve traffic, under the smart mobility, improve the traffic management through the use of navigation apps, journey planner, smart card, signal control system, and etc. So these smart transport technologies notify travelers about traffic and other road conditions through the variable messaging systems, guide driver to the available parking spots, and detect traffic accidents. I think this is very close to everyday daily life, especially for the urban dwellers. Another one is about the smart water and energy. So based on the smart meters that we use in water management and energy management, smart meter gather all the data about energy and water demand and users. So this data enable city to regulate supplies for the service providers and etc. For instance, to supply more water or energy to certain part of the city that consume more resources. So this can be a very good indication for the service providers to channel their resources and etc. Cities can process data from IoT devices and sensors to recognize pattern and needs. For us as a city administrator, this analysis can reduce the number of road accident, for example, and congestion, and help driver to find a parking spot. Data can also reduce crime, improve smart urban lighting, and improve water and energy system. So modern analytic capabilities can help understand the real situation and challenges of a city through data. Based on urban analysis, comparative analysis, data management is an integrated platform towards more effective and efficient policy formulation. So the use case that on top of that, the use case that I like the most is something related to climate change, because I think this is an issue which is very close to our heart. Yesterday, Kuala Lumpur just experienced another flash flood. So we know that the microclimate is real and is a challenge to any cities nowadays. So urban heat island, or UHI, is another issue that can be mitigated using a smart technology and IoT devices. Through multiple IoT weather-related sensors, cities can simulate the land surface temperature. And from that, we can use nature-based solutions, such example, landscaping strategies to mitigate hotspot area identified by the map. So this is a combination between a tech-based, using all the IoT sensor, and also the solution using the nature-based solution. So this basically can reduce the land temperature in the cities and reduce greenhouse gas and give more better ambient to the city dwellers. Just to sharing with all the audience, now Malaysia at the federal government level, we are developing what we call as a big infrastructure called Malaysian Urban Observatory. So this is a very big project called as the Big Data Analytic Platform, try to integrate all the smart city integrated operation center that we have throughout of the cities in Malaysia. And we want to use this data as an insight for the future cities planning and management in Malaysia. Thank you.
Thank you. Yeah, my next question on a little bit about the future to Jian. What are some of the future trends in development of smart cities that you see around as you do business with your clients?
Yes, based on several years analyze, we have some tendency, we can say, for the future smart city development. The first is a construction mode. Okay, and before the construction mode is more like the independent infrastructure, but now or in the future it will be more like overall, construction. So the networker will develop from a single point to the overall planning. Okay, so this is the first trend. The second one is the operation and the maintenance mode. We think before it's more like the decentralized operation, but in the future, it will be more like co-construction and the sharing and the unified management and the centralized operation in the coming future. The third chance we think is the investment. Before, the investment was mainly from the government, but in the future, investment is multi-parts investment. You have funds from government, but maybe more and more capital were from the social. So that's the trends we think in the future. Thank you.
Thank you. Switching a little bit gears towards the development of the smart estate or the platforms for smart cities. Question would be to Charmaine. It is practically impossible for one team to build all the use cases for a large estate, right? How this open digital platform that JTC is trying to build or already building facilitates the ecosystem collaboration among different partners?
Thanks, Sadvik. Yeah, we do recognize that we cannot build smart cities alone, right? And having this ecosystem where all the different stakeholders can come together to form partnerships to leverage on our respective strengths, be it in the public or the private sector, is increasingly important. For me, I would think that the smart city ecosystem requires not just cooperation, right? It also requires things like your technical compatibility among your different users, your different stakeholders. So for example, setting standards, industry standards, and also having open and interoperable interfaces would definitely be helpful in fostering such an ecosystem. So one such way is to have a smart city OS, or in this case, ODP. It can form this interoperable layer to help to orchestrate all your different smart city systems and also your delivery of services to meet your different needs of the citizens. So ODP, one of its key capabilities is actually offering an interoperable layer. So if I can draw parallels to Android OS, the ODP actually provides an open standard and a multi-protocol middleware layer that allows for different systems to connect to it. So we offer things like protocol translators or drivers for different systems. So you have your lifts, you have your building management systems, you have your doors, your CCTVs. We have protocol translators and drivers for this. So these vertical systems can easily connect to us. And in terms of allowing users to use our data, we can provide APIs. So your third-party operators, your other government agencies, companies, or even the public, they can call these APIs to access curated data. So you can use this to build their apps and services on top of the ODP. So not just that, we have the ODP, we have also, because we are also the master developer of PDD, what we do is we design and build district-wide infrastructure within PDD for integration with ODP. So all these different systems can then be interconnected and speak to each other easily. So what happens is that instead of having to integrate each individual vertical with each other, so for example, your lifts, you need to integrate them with doors, with the CCTVs. In the past, you probably need to do them, individually, but now you can just integrate each vertical with ODP just once. So that's how you can also reduce integration costs. And ODP also helps to enable this kind of system-to-system communications, and you really allow the infrastructure developer to start to integrate all your smart systems and technologies in areas such as your facilities management, your security, and like autonomous goods deliveries. So that is one way in which how ODP can offer to can basically foster ecosystem collaboration. Another way is, earlier I mentioned that digital twins is another capability of ODP. So with a digital twin, you can start to collect all your data and you can replicate them in a digital twin. So companies can actually come and use ODP's digital twin to experiment and really test bit their solutions without actually compromising any actual functions of the district. So ODP also provides this platform where different companies can come together to come up with solutions. And finally, because ODP is built using a microservices architecture, so it's really easy for example, if you want to do AI machine learning, you can have other players come in to plug and play their models to use the data that we have. So I think in total, these three key capabilities of ODP really allows us to foster such ecosystem collaborations to really push forward for a smart district.
Thank you, Sharman. My next question would be to Farabi again. So you talked about climate change and how IoT can help in the climate change. So next big topic is the carbon footprint reduction. So Malaysia has big plans, ambitious plans for carbon reduction. How do you see policy making and regulations related to smart cities play a role in achieving the carbon reduction goal that countries have?
Okay, thank you. The question is, you talk about the policy and regulation, right? So now Malaysian just entering the 12th Malaysian plan. So in the 12th Malaysian plan, Malaysia is at a tipping point in the fight against the climate and biodiversity crisis, as it step up effort and commitment to transition to a low carbon climate resilient economy. So in Malaysia, there is a lot of I would say the players and also the champion in this area, because we also have the Environment Ministry as well, which just come up with the National Low Carbon Cities Master Plan. It's a national strategy to promote urban development while reducing the energy consumption and greenhouse gas emission. So to achieve this, the master plan adopt, if not mistaken, the 3M approach. One is measurement, management, mitigation of the GHG emission to reduce environmental impact. On top of that, in my ministry, actually, we come up with the Malaysian Smart City Framework that I mentioned earlier. So it's a national level framework that was developed taking into account the importance of smart city development and implementation in Malaysia. So this will be a catalyst to smart city implementation, especially in Malaysia, and especially the term smart city and low carbon cities has been used interchangeably. So this is very important to have the alignment. What are the actions that we need to take into consideration, so that is the action will tackle both issues in terms of the smart and also the low carbon cities. So there are 7 components in the smart cities, which is encompasses from smart economy, smart living, smart environment, smart people, smart government, smart mobility, and smart digital infrastructure. So with regard to the low carbon that you mentioned earlier, so under the energy efficiency, the framework proposed making government and commercial building comply with the building energy efficiency requirements, such as implementing renewable energy initiative and building energy automation system. It also proposed the implementation of the smart grid technology and building the nation's renewable energy capacity. So with regard to mobility as well, I think mobility is one of the most contributors to these emissions. Effort will be put into establishing intelligent transport management system, real-time data on public transport services, traffic congestion, energy use, the air quality are gathered and processed daily using the big data, IoT sensors, network and application by a centralized traffic command we have in Kuala Lumpur called Intelligent Transportation Information System, ITIS, which would allow city to better monitor and increase the efficiency of their services while contributing to the lower carbon emission. So many municipalities in Malaysia understand and recognize that cities are the key contributors to the climate change, and urban initiatives are the main source of greenhouse gas emission. Thus, local government or municipalities are at the forefront in addressing emerging environmental issue. In addressing this climate change, most local authorities are either guided by the local guidelines framework or rely on international organization bodies related low carbon development to implement the GHG reduction measures at the city level. Nevertheless, some cities have developed their own action plan to reduce the GHG emissions. So this is very localized and very unique to every city. So I do believe that all ministry, all agencies have done their part, but what we need to do now is more to establish more smart partnership, to have a more concerted effort in our battle with the climate change and also with the pandemic COVID-19 as well. Thank you.
Thank you, Farabi. To question to Gian, I was reflecting on the point that you mentioned about is smart city is not about just buying hardware or solutions, right? It is about the use case and the value. So I wanted to get your perspective, Gian, on the what is the value that IoT solutions bring in terms of overall smart city scheme of things.
I can say that for the IoT technology, what value it can bring to smart city as first is for the hardware side, we can use the IoT technology or standard to establish a unified access standard. Then all the department or different level of the city, they can share the device. They can has a unified management for all the device in the whole city. So I think this is the most important value we can bring. The second one is for the platform side. Since we have the smart city terminal, the device, then we have chance to collect all the necessary data. And then based on the big data technology, we can make the virtualization of the platform. Then everything you can see from the cloud, you can see from the platform. So this is the second big value I think IoT technology can bring. Thank you.
Thank you. Okay. Again, going back to some of the use cases, Charmaine, maybe a question to you. What are the top 3 use cases that you think that has a clear business case?
Okay, thanks for the question. Perhaps let me talk about the recent Continental robots proof of concept that we just concluded. So given that autonomous delivery robots will be part of the smart district landscape in PDD in future, we have done a trial with Continental to basically see how they are able to have the delivery robots send food from Westgate, which is a nearby shopping mall, to JDC Summit's office building. So this POC allowed us to study a few things. So for example, we had a few questions. How is your robot going to clear the turnstiles in your buildings, to enter your lift lobby, to enter your lift, to go to the correct floor, and then deliver it to the correct office building where your person is waiting for his food, right? So how the ODP actually does this is by providing, again, this middleware layer and also protocol adapters for your robots to basically connect up to ODP and then talk individually to your turnstiles to tell them to open the turnstile for them to go through to the lift lobby, and then call the lift to level 1, and then let the lift know that, you know, this robot is going to level 10, and then the lift will bring it to level 10, where the robot then has to navigate his way to the specific office floor. So all this can be done with the help of ODP. And how this is also done is when the robot actually connects up to the ODP provides the robot with a 3D building plan. So the robot knows for one where is his destination. So he's able to navigate throughout the JDC Summit with the help of this 3D building plan. So of course, this is just one robot. In future, we expect to have more robots. So another challenge will be then, how do we ensure that the robots don't collide with each other, for example, right? So that's why we are still developing a robot traffic marshalling system that will allow your different robots from different vendors to operate smoothly within the building. And we are doing this using ODP as well as the middleware layer. So with us being that middleware layer, we can then have some form of control over the robots, but not in the sense that we tell them to, we cannot actually control their direction. We can tell them to start and stop. So that's essentially what the robot traffic marshalling system does. So that's for autonomous delivery robots. I think the second use case I'd like to talk about is how our FM colleagues at JTC Summit is currently using ODP for smart facilities management. So they are actually making use of the C3 capability of the ODP, which allows them to have a real-time command and control of all the building systems in JTC Summit. So earlier I mentioned we managed to plug in the lift, the building management system to ODP. So now what our colleagues can do is they can actually control your BMS air conditioning valves to like cool down or warm a room, for example. So you're actually able to control and actuate certain building systems from ODP itself. You don't actually need to go to the actual room to turn on the aircon, turn off the aircon. We can now do that from the command center where our FM colleagues are. So this also gives them an overview of all the statuses of your building assets. Where are the locations of your building assets, for example? So statuses are things like your lifts, are they in operation or are they in maintenance mode? You don't actually have to be there to know that. You can tell it from the ODP interface itself. And also with robots, right? Now we have a cleaning robot, we have a delivery robot. You want to know where your robot assets are, and ODP also allows you to do that. So I think the final one I'd like to talk about is AI controlling estate systems, how we use AI to actually cool or manage the energy within a building. So with IoT sensors, we don't just collect data, we don't just stream data. What we can do now is also to control and actuate systems from command center, for example. So this is also ways in which we can make buildings more responsive to their occupants. And in this way, we can help to enhance their quality of life. And also in tandem, we can achieve energy and resource savings. So the IoT data that buildings produce, right, actually allow us to understand how buildings actually perform and how they react to people in the building. So for example, we can collect data on how people have been using the spaces in the building. We can install CCTVs, analyze the people movements, or we can install people counting sensors so we know how many people are in the building at any one point in time. So for example, if there are more people in a certain zone, the building can react by cooling your area automatically to make it more comfortable for them. Or we can also go one step further to have the building respond to external stimuli such as the weather. So for example, if your surrounding air temperature is warmer, we can look at cooling the area more. So this is also where AI ML can come in to learn from the past data that we've collected, and also be used together with physics-based models to study how we can balance energy optimization without compromising thermal comfort. So in a way, digital twins again can help in this area because we are again able to carry out simulations to understand what are the effects of making certain changes to the building systems. So for example, if you want to open the damper a bit more so that you allow more airflow to the room, we can do that virtually in a digital twin without actually having to make these changes in the real world. So I think that's the real value of digital twin and also AI ML technologies.
Thank you. Thank you. You're really bringing us to the future, Sharmaine. Thank you. Very futuristic. Looking forward to seeing it in real life in the PDD. Probably my last question related to what Sharmaine has told to Farabi. So the urban mobility landscape, right? Imagine with autonomous vehicles, electric vehicles, robotics, all this. So urban mobility landscape is changing, especially with the electric vehicle. There will be a large new infrastructure for charging that is required. What is your view and where the policy makers are thinking towards this, Farabi?
Okay, thank you. I think this when talk about the electric vehicles or EV is very a new area, and actually I'm not so expert in this area because we have another agency called Malaysian Green Tech Technology, MGTC is the one who in charge of this. But from my understanding, when it comes to electric vehicles infrastructure, one of the most important thing to take note is the number of DC fast charging stations that are available. It is what remove range anxiety, which even a short 15-minute top up would suffice to get where you you need to go. In Malaysia, I believe there is about 500 public AC charging station in Malaysia and only 9 public DC fast charging station for EV with another 10 in development. So in my view, Malaysia is lagging behind its regional peers when it's come to the AC charging station. But I do believe the planning is in the pipeline. So the country now aims to have more than 1,000 DC rapid charging station by 2025 or in the next 3 years. As part of the implementation strategy under our Malaysian Smart City Framework, so the ministry have introduced the Malaysian standard on smart city indicators to measure the smartness of the city. So one of the indicators is to highlight the number of electric vehicle charging station per registered electric vehicle. So with new introduction of this standard, I do believe the local municipalities and also private agencies will expedite the implementation because there is already policy set on that, and it will provide we can see this implementation throughout of the municipalities in the near future.
Thank you, Farabi. Thanks everyone. Thanks for your great insights and answering all the questions. Thank you very much.